Here, these next ones, we are going to evaluate limits that we already know. So we should already know that the limit as x goes to 0 of sine x over x is equal to 1. That really should be an identity at this point. But now, even though it's an identity, we can confirm this with L'Hopital's because we have a 0 over 0 form. If I apply L'Hopital's, I end up with limit as x goes to 0 of cosine x over 1. I can evaluate this limit. Cos 0 is equal to 1 over 1. There it is. We can confirm we're using L'Hopital's rule, something we already knew. Sine x over x, the limit as x goes to 0 is 1. This one here we did in homework where we took the derivative of sine ax over x. This one should end up being a. So let's just double check here using L'Hopital's. So again, plugging in 0, I get 0 over 0. There's my condition. Apply L'Hopital's. The derivative of sine is cos. And I need to make sure I apply chain rule. So times it by the a over 1. I can evaluate this limit. This becomes a. Cosine of a times 0 is cosine 0, which is 1 over 1. And again, now we confirm that value of a. Okay, and this is something that we saw in some of our homework examples previously. This one here is a little bit tricky, but this one, if we approach sine the log x as log of 1 is 0. Okay, if I plug in 0 here, I'm going to plug in 1 here. 1 minus 1 is 0. Okay, so I have my condition to apply L'Hopital's rule. So here it goes. Let's apply L'Hopital's. So limit as x goes to 1 from the positive side. I can differentiate the numerator independently of the denominator. Okay, so there it is. As I plug 1 in, I end up with 1 in the numerator, 2 times, well, that's going to be equal to 0. Okay, it's approaching 0 from the positive side. Okay, so if I'm approaching 0 from the positive side, it's going to give me 0. I'm just going to put a little positive side there. So I'm dividing by 0 from the positive side. Well, that works out to be positive infinity. Okay, so if I approach 1 from that side, I'm going to end up with positive infinity. So we'll graph these. I'll show graphs of these. But again, you should be graphing these yourselves. In fact, I'm just going to let you graph these yourselves and confirm that this is in fact the case. Okay. So this one here, we are going to approach 0, e to the x. So when I work this out, this is going to be e to the 1 minus 1 times, as I approach 0, and this really should be from the positive side because it needs to be a one-sided limit. So that's a typo there, so if you can fix that. As I approach 0 from the positive side, I end up with negative infinity, which is 0 times negative infinity. Well, we can't work that out, but what we can do is I can rearrange this into, a ratio form, which I can then apply L'Hopital's rule to. So as x goes to 0 from the positive side, I'm going to put, which one should I put in the denominator? I think maybe it might be easier to go log x in the numerator and 1 over e to the x minus 1. In fact, I'm going to rearrange that because now that becomes, I have to be a little bit careful because that's going to be a power rule that I have to use on the outside. So that now becomes an embedded function. So here, this time now I end up with, actually I'm going to leave it as a fraction first to evaluate it. So 1 over e to the x minus 1. So this becomes negative infinity for the log. 1 over e to the x from the positive side. So it's going to hit 0 from the positive side. That becomes negative infinity over infinity. Okay. So I now have my condition for L'Hopital's. So at this point, I can apply L'Hopital's rule to this one. Okay. And again, notice this would have been really complicated to figure it out. But now, because I have this L'Hopital's rule, watch what happens. I get differentiate the numerator, log x becomes 1 over x. I can differentiate this. I'm going to do it as power. So I'm going to do e to the x minus 1. We increase the power, so negative 1 becomes 0. Okay, and then we're going to divide by 0. Oops, sorry, what am I doing here? Differentiating that becomes negative 2, sorry, negative 1 to the power negative 2. Okay, just so that you kind of, I'll just do it off to the side here. That was e to the x minus 1 to the negative 1. The derivative becomes negative 1 e to the x minus 1 and reduce the power by 1. Okay, so that's how I got that expression. Okay, so I'm going to plug in and see what happens here. Okay, I'm going to end up with, I'm going to go to 0 from the positive side, so that's going to be 1 divided by 0. Okay, so that's going to be negative infinity. I'm going to, so positive infinity. I'm going to plug in my 0 from the positive side here, so it's going to be 0 from the positive side, negative 2, so that's going to be dividing by 2, so I should rewrite that, make sure that you can see what's going on. Put the negative on top. It's going to be 1 over 0 from the positive side squared. That's going to be negative infinity over positive infinity. Okay, so then I can reapply L'Hopital's again. I have my condition. Okay, here I'm going to end up with, let's see here, you know what? Let's simplify this a little bit. I just realized we could have actually simplified this a bit here, because we could have rewritten this as the limit as x goes to 0 from the positive side. Well, that's a negative exponent, so I'm just going to put that as a positive exponent in the numerator, and then we'll put that x in the denominator. So this is a little bit easier to see. We have, it's going to 0 in the numerator, and it's going to 0 in the denominator. Okay, so we have our condition again. So this is much easier to differentiate, so I'm going to differentiate this. So we're going to apply L'Hopital's. As x goes to 0 from the positive, apply L'Hopital's again. What happened to that there? There we go. And apply L'Hopital's. E to the x minus 1. Oh, I made a big mistake here, didn't I? Yeah. Okay, I'm going to have to go back here. I forgot to apply chain rule here when I differentiated this. So I differentiated the outside. I forgot to apply chain rule, e to the x times e to the x here. Okay. So you're going to have to back up there. Okay, so I forgot to apply chain rule, so this is what it looks like now. I'm going to rearrange it so that it looks a little bit nicer. So limit as x goes to 0 from the positive side, the negative e to the x minus 1 negative power becomes positive in the numerator. X comes down here, and that e to the x stays down there. Okay, so here I have, this is equal to 0 over 0 times 1, which is 0 over 0. Okay, so I have my condition again. Now I'm going to, I can apply L'Hopital's to this expression. So sorry, I forgot about that extra e to the x, so I need to make sure that and this was wrong here, right? Because as I apply here, I have to apply the chain rule times e to the x. Okay, so applying L'Hopital's one more time. E to the x limit as x goes to 0 from the positive side. I'm going to apply it to this expression here. So applying L'Hopital's. It becomes negative 2 e to the x minus 1 times e to the x. Okay, this is going to become e to the x plus x e to the x. Okay, that's my denominator. I'm just going to cancel out some factors here and simplify this. So limit as x goes to 0 from the positive side becomes negative 2 e to the x minus 1. Okay. Did I do that right? Yeah, that looks right. Okay, and then I'm going to cancel out those factors of e to the x, so I end up with 1 plus x. Okay, so finally here I think I have a form which I can evaluate. I'm going to end up with going to 0 from the positive side, so it's going to be 0 times negative 2, and 1 plus 0, well, that's going to be work out to 0. Wow, took a long ways to get there, but there it is.